Hello, everyone. Thank you for joining us today for our IV6 VenuePolar software webinar. My name is Dave Howden. I'm Technical Services Manager with the Loudspeaker Solutions Group based in Chester, Pennsylvania. So again, thanks for taking the time, and let's get right into things here. So the IV6, most of you are familiar with it. Going to do a brief overview though. It's a modular, adaptive, scalable, vertical array, which it's been available for almost 3 years on the market and growing in popularity by leaps and bounds on a quarterly basis for sure. Indoor, outdoor models are available, made at our plant here in Chester, PA. A few example applications just to keep in mind as we go through this, the sorts of facilities where we most commonly see the IV6 systems applied. Auditoria is obviously a popular one. Worship spaces, performance venues, small to medium size, both indoor and outdoor systems with custom rigging. We can also do some pretty challenging spaces. If we build a long enough array and acoustics are enough on our side, we can address some fairly large spaces too, like this system that projects close to 50 meters in this space. So the system review: high performance, high output modular vertical array and subwoofer system. Easy to configure, low profile hardware that's designed by Polar Focus and manufactured by them for us. There are two full range elements in the series. You have a 5-degree vertical and a 15-degree vertical, both with 120-degree horizontal dispersion. Note that the elements are 16 ohms. They are intended to be paralleled together in multiples, not an amplifier per cabinet like many modular vertical array systems. We also have a subwoofer. High power single 18, which is very similar to our I-series single 18 subwoofer, but its size, it was designed to be able to live in the array, behind the array, or could be used as a ground stack element on the ground. So a lot of different configurations which we could do with our indoor array frames. We could do sub behind, subs in the array, no subs, and we also have a low profile flybar also that is not compatible with the subwoofers. The GlidePoint array frame is our most popular system. It's a single point hang, and it can support a very large number of cabinets. It has an infinitely adjustable carriage on the top that can move back and forth to get the proper down angle. It can also be adjusted under load, even after the array is built, flown in the air. The carriage, just using a open-end wrench, move it back and forth to just change the increment of down angle up, a degree or so, depending on your needs. Once you get the system flown in the air. And our PY1 hoist ring, that's what's most commonly used with this system to get the system up in the air. So simple to use, easy to use, very efficient system. We also have a sub-behind array frame, again, infinitely adjustable, lift point. Two different balance points in this when you're doing subwoofers behind the system, so you won't actually find this rigging accessory in the Ease Focus software. A little too complicated with all the ways it can twist or turn. But this allows us to do our subwoofers behind hang. We have a calculator and cornerstone, which you can make use of if to determine the balance point of your subwoofer and full range array. The light array frame, or pullback bars, as we often refer to it as, is only for suspending the 1122 elements. It is a lower cost, not quite as much flexibility, but for your 4, 5, 6 element arrays, it can be very effective very useful system, and it can still hold up to 10 IV6 elements as long as you can get the down angle needed out of it, based on the mechanics of the light array frame. But wonderful budget solution. Again, you cannot hang subwoofers on the light array frame, but has many other uses, and if you have ground stack subs, that's just not a problem. So what's not new about the IV6 is the passive acoustic optimization, but we have greatly expanded on it with VenuePolar. But PAO provides the ability to shape the IV6's vertical lobe through passive beamforming, that is passive attenuation of the components. Again, we don't have an amplifier per channel with this system. It's a much more cost-effective system than many others out there, and provides a lower cost of install because we are paralleling elements off the same amplifier signal. PAO uses both mechanical and electrical algorithms through a custom API in Focus 3 in order to do that passive beamforming. There's 3 splay increments in between the cabinets, the 1122 cabinets, which are considered in the calculation of the array. Each IV6 supports 55 different response profiles via the rear jumper panel to contour the full range and the high frequency of the box, which when combined together with a number of other elements, that's what enables us to provide very fine control of the passive beamforming. As I said before, all of the full range elements receive the same amplifier signal as they are driven by the same FIR DSP setting. So again, we're not looking at an amp per box or 2 amps per box. Okay, one, and depending on the size of the array, maybe 2 amplifiers, but just the same DSP FIR file applied to those. Rigging the IV6, I mentioned there's 3 different splay plates available that provides us either a tight pack, the S1 plate, 0 degrees in between plates, see on between cabinets, see on the right on the bottom, a 2.5 degree or a 5 degree increment. We didn't burden the IV6 system with 1/2 degree adjustments in between the elements, and the more expensive rigging. We found after much experimentation that this was just fine. The side of the cabinets are shown, looks like a handle. Yeah, there's a handle on the side, and that's very convenient for the installers when they're building the array. But once you're done installing the hardware, all of that, including the cup handles, are concealed by a cover plate after installation. The contouring controls that I've mentioned, where we could come up with those 55 different profiles, are on the back of each full range element, provide a very wide range of control. We're able to attenuate the entire cabinet or just the high frequency. Our HF attenuation control isn't simply reducing the overall level. We're not just putting a resistor in line. We're actually changing the crossover point and the response of it depending on the attenuation to still maximize the integration with the woofer, which is something that most other companies are not doing. They can turn down their high frequency, 3 or 6 dB, but we've gone to great lengths to maintain good summation at the crossover. We have 15 decibels of full range attenuation available in each element through a very high quality autoformer that we designed and built. Do that, of course, rather than dissipating a whole bunch of heat inside of the cabinet when it comes to the full range side of it. And the high frequency taps, again, we have 6 dB of high frequency tapering capability and 1.5 dB steps. A lot of different response profiles. Don't worry, those of you that are new to this, you don't have to figure it out. The software is going to help figure it out for you. All right, so what is VenuePolar? That's what we're really here to talk about. VenuePolar is a software plugin API for EaseFocus 3, and it's exclusive to the IV6 system. It automates a number of array design processes. It will calculate based on your input data, what element types are in the array, what the intersplay is, whether it uses the 0, 2.5, or 5 degree splay plates between elements. And it also calculates the full box and the high frequency contour profiles, as we just saw on the previous page. And it'll also provide a subwoofer quantity estimation based on the array size and target SPL. Provides predictions based on the properties of your modeled seating areas. And I can't stress enough, how important it is to do a proper site survey. When you're going out or get very detailed drawings, we need to qualify where, if IV6 is an appropriate system for the space, where can we place the array? Where is it going to work aesthetically? And also, is IV6 appropriate for the room acoustics? VenuePolar is a very precise algorithm, and the difference between moving the speaker forward and back, whatever, a half a meter or a foot or so, probably not going to affect things too much. But if you need to change a position, 4 or 5 feet when you get on site, as opposed to how you modeled it, that could affect what VenuePolar's output would have been. So make sure you figure out your hang position options early on before you commit to buying the BOM. A prediction's only as good as the accuracy of the seating areas that you enter in EaseFocus 3. Again, just stressing this, we're doing some very high-level calculations here, and we're really getting it right. So make sure that the site survey information or your drawing information is absolutely accurate that you enter into EaseFocus. We do have a lot of flexibility depending on the needs of the system, within VenuePolar to specify, the desired SPL and other attributes of a system in order to achieve that even coverage of the space that we are working in. And VenuePolar's primary goal is we want to be easy to use. We want to make designing quick. Yes, you've got to qualify the room and the acoustics of the room and that it's the right system for the space. But we want to have an efficient design process in a common software package. VenuePolar API, for those of you that have been using the IV6, the version 2 GLL, with just the PAO in it, it's a giant leap forward in functionality and how much work that we're letting the API and the software do for you and the predictions that it's making. There's a lot of highly intelligent automation built in to the API, and it greatly speeds up the design process. I'd say that now I can design an IV6 system in maybe 1/3 of the time as with the previous 2.0 GLL with just the PAO module. But that's the idea behind VenuePolar. It's gives us great results quickly. Intermediate users, great can quickly and easily achieve, great performance in common, relatively acoustically friendly spaces. While the advanced users will really appreciate the wide range of user controls and adjustability that you can do inside of the VenuePolar module for your more complex needs, and will provide you with extraordinary outcomes for your system designs. So how does VenuePolar work? Now, for any listening area, we want uniform sound coverage. We want first to last listener to have a very similar listening experience, including frequency response, sound pressure level, hopefully intelligibility, which EaseFocus doesn't calculate, but we need that. The calculator array needs to counteract the SPL loss over distance, or inverse square law, if you will. And this is based on our D2 D1 ratio. D1 is shown in the picture being the nearest listener, and D2 being the furthest listener. And very often when we're doing these auditorium or deep spaces, it's not uncommon for there to be, just based on inverse square law alone, a 20 decibel difference between the first listener seat and the last listener seat. And often that'll eliminate a simple left-right point source system in a space because we cannot get the even distribution of sound pressure level. Sure, you might be able to put delays in a room, deeper in a room, down the walls, but a lot of people just prefer minimum number of speakers, left-right system, maintain your imaging at the front of the room. So for an IV6 array that VenuePolar is working with, several variables that it's looking at to produce the VenuePolar and achieve this uniform sound coverage. VenuePolar kind of works backwards from the room geometry to predict the required array to satisfy that even coverage and SPL, just as a designer would consider the room first and then work backwards to what the appropriate technology is for a space. So VenuePolar will, based on your model, predict the number of elements, the vertical pattern of each element. It'll assemble them into an array. It'll figure out the splay angle in between the elements, which of those splay plates are used to achieve that vertical pattern. It'll figure out the attenuation profiles or the magnitude of each element's frequency range, whether it's the full box or just the HF contouring controls. It will tell you where to set those controls on each full range element. So if we consider all the above, we can calculate an array that has a proper vertical pattern and intensity, or SPL, to address the listening area that you've drawn in. This is what we call the VenuePolar. We're creating a polar to fit the venue, and we're doing it in a very, very easy fashion. We still retain many of the unique features found in the prior release of the GLL. We still have the mechanical loads and safety factor calculator built in to VenuePolar. You still have the ability to fine-tune the array sum. If you look at it and really scrutinize the frequency bands, you can get in there and tweak things. If you think the HF needs to be plus a half a dB for the front row, you can still go in and make these adjustments very easily. But it's VenuePolar, 95% correct, and resulting in even coverage from first to last listener, based on my experience with it. We also received detailed reporting out of the EaseFocus package, which will include all of the rigging hardware required for it, number of splay plates, and very detailed information so that the installers on site can put the array together properly. And I think it shouldn't be lost in all this that it's a familiar EaseFocus 3 workflow. It's not another Aimware program to learn. So we tried to keep it simple in that context also. And for the more advanced users, you can you can export the array configurations to ease4 if you want to do more acoustic studies or more in-depth studies of it. EaseFocus 3, doesn't get into acoustics. We're working in direct SPL only, and there are those more challenging rooms that might benefit from more detailed analysis. So start in EaseFocus 3, configure your arrays, and then you can export the configuration with all the VenuePolar attributes into your EaseFour model. VenuePolar also provides a lot more support for subwoofer configurations, which we previously had not really approached in the prior GLL. We have the ability to suggest a quantity of subs based on the array size or the SPL desires of the system. We can place them in or above the array, if you will, behind the array, as we saw as an option. We can ground stack the subwoofers, IV6 subwoofers, or any I-series subwoofer out of our line for that matter, if that makes more sense. Or we could just choose no subwoofers for the system. A lot of flexibility there, though. As I said before, for the sub behind configuration, use the sub behind point calculator to determine the array balance point, which is available as a cornerstone download. So let's take a look at some things we're trying to solve for here. A typical point source radiation pattern in a room, generally not ideal for a long throw system. You see that our front listeners are getting a lot of the energy, and we're certainly not making it to the back of the room. This is one of those situations, for this depth room, which is probably 75 feet. Point source probably wouldn't be a good choice. But using VenuePolar and allowing it to predict an array, for the space, we're able to create a very optimized vertical radiation pattern, which provides that very similar experience from first to last listener and distributes the energy accordingly. And again, we're doing all this shaping using the passive contouring controls on the back of each full range element, simply by attenuating them. Obviously, you're probably attenuating the lower cabinets more than the upper cabinets, allowing them to reach further into the space in the more near field cabinets, attenuated down whether full box or a combination of the full box and the high frequency, in order to achieve that even front to back coverage. So let's get started. Let's take a look at what we need to do to get working with VenuePolar. First, a requirement of VenuePolar is you must have EaseFocus version 3.1.12 at a minimum. Older versions are not compatible with the VenuePolar API, so make sure you're at least up to 0.12. And you'll of course need to download and import our new GLL, which is currently versioned as 3.03. You can find that in the downloads area. Go to community GLL data, and you could download the EaseFocus GLL from the community section as shown below. Once you download the GLL, extract it from the zip file, place it somewhere where you can find it. Most of you know how to import a system definition file, so get that 3.03, that 3.03 version of the GLL. It will show up as the Biamp IV6 modular vertical array 303, and inserting a speaker, as always, just that same icon at the top of the screen in EaseFocus. One note, since VenuePolar is an add-on API, the right side of your screen, if you do have an IV6 array in your project, and it is the VenuePolar version 3, You may need to turn on the second properties window under your view settings if you do not see this on the right-hand side in order for the VenuePolar properties to show when you select your IV6 array. Go through some of the tabs here. There's a lot of different settings that you can do to affect how the VenuePolar is created. But first thing that I want to point out is there's a web help button that takes you to a page that goes into more detail on each of the settings within VenuePolar. So as long as you've got an internet connection, you can go to that web help page. Otherwise, we just have our tool tips next to each of these systems, next to each of these settings to give you a brief explanation. Most of them are pretty self-explanatory, but target audience areas, this is where we select the areas for the array calculation. You can right click on them to check or uncheck them. Those that are grayed out generally indicates that the aiming lines for an array are not intersecting that audience area and they will remain unselectable. We can enhance the front row coverage, which in some cases it might mean the array just gets down tilted a little bit more. In other situations, it might end up adding a box to the bottom of your array. It's all really a function of how far that array is from your first listener seats. If it's right on top of them, yes, it's probably going to add another box to the bottom of the array. Minimum target SPL based on A weighting, we can enter that. We can enter that here. Relatively self-explanatory. Optimize down to the default is 800 hertz. If we want to optimize more for low frequency and have more low frequency pattern control due to acoustic concerns, you might decide that it's a good idea to optimize to a lower frequency. But again, that's going to give you a longer array, which is required for those longer wavelength frequencies. Last row offset, we can, sometimes you want to overshoot the back row in a space a little bit. Maybe you're going to have people standing in back, or perhaps you want to undershoot it because you've got a glass wall behind the last row of the seating area that you defined in ease focus. This allows you to easily basically raise or lower the energy that reaches the listening plane for the last row that your audience area covers. There's also times where we know we can only work with a certain number of elements. We can restrict the number of elements in VenuePolar, and VenuePolar will do its best to calculate, based on the other parameters, usually primarily SPL. It'll do its best to optimize that limited number of elements, but it'll also tell you if you don't have enough. It'll give you a warning if VenuePolar determines it just can't work well for that space, and maybe you need to consider another array or more elements, or give us at the loudspeaker solution group a call. Subwoofer options, we could do all those. You can use the the IV6 subwoofer. Obviously, that's the only one that'll go behind or in the array with our rigging. But if you're doing a ground stack sub, you could put any subwoofer in there you want to. You'll just have to insert it as a separate GLL within the space. But VenuePolar will calculate if you tell it to put subwoofers in or behind the array. It'll make a good estimation of how many subwoofers based on your target SPL of the system. And calculate array, that's where it all really happens. Press that button and it does all the calculations and predicts the proper array for the space. Once we calculate the array, it's shown in the array tab. Notice we've moved from the start tab to the array tab on the right, and we now need to synchronize the array on in the main screen of EaseFocus 3 to match the suggested array on the right-hand side. We will take a look at that in more detail. The VenuePolar to EF3 sends the array and calculation from VenuePolar to the EaseFocus calculation engine. If it's disabled and you've got red text, that means you've got some work to do adjusting the array in the EaseFocus main screen, but again, we will take a look at that. If you decide to manually optimize the attenuators in it, remember you've got to use that VP to EF3 send button to send it back over to the calculation engine. We also have the ability to bring in a pre-configured array over. Maybe you calculated it in VenuePolar, maybe you didn't. We can bring it from EaseFocus into VenuePolar and allow you to adjust the filter settings in the VenuePolar module. Again, rigging safety check module is still there, and under the loads tab, it defaults to a 10:1 safety factor. You can change that if desired to. All right, example. Let's go through one quick, then we'll do one live. So first thing we need to do, we need to build our model. Again, accuracy of your audience areas and listening planes. Extremely important in VenuePolar because it's calculating them based on your input data. So as with any EaseFocus project, draw your planes, give them the right elevations if applicable. We'll place our IV6 array in its intended XYZ position, and initially, when you bring it in, you could ignore the box quantity because when we calculate it, it will predict the proper box quantity, but it comes in, I think, as 12 boxes at this point. But you could ignore that for the time being, don't worry about it. And don't worry about auto-splaying. We don't need to do the auto-splay in the EaseFocus screen. VenuePolar is going to take care of all that work. What you need to do is get your XYZ position correct, get your horizontal aiming, put your aim line where you intend it to be across that audience area. And a very important note here that VenuePolar can only calculate for audience areas which its aim line, its red aim line fully intersects. You can't have an array over an audience area and have it consider that audience area in the VenuePolar calculation. As shown here, it will consider both of these audience areas since the aim line fully intersects both of them. When we get everything set in this window, we can choose our target audience areas. You may have reason not to optimize for both of them, but in the example I showed, we had an upper and a lower seating listening area. If there were other audience areas that the line didn't intersect, they'd be grayed out. You can right check to select or unselect all. Over the array characteristics, we can now dial in the characteristics we want for the array. Our target SPL, which we set for 103 dBA here, leave our optimization and our other settings as they were, and I'm not doing any subwoofers in this array. We simply click Calculate Array. So when I hit Calculate Array, moving left to right on the screen here, it will show an array in the VenuePolar screen that's suggested, but we now need to synchronize this. First thing we need to do, as the red text is indicating, change box count to 5 in EaseFocus 3. Okay, so do that. EaseFocus 3 brings in boxes as 5 degree. This system wants 15 degrees. Then we'll go back and change the cabinet types 1, 2, 3, 4, and 5 to 15 degree. Once we do that, we get a green cabinet quantity and model synced. It's the green light for go. Then we can press our VenuePolar to EF3 button to send the VenuePolar data to the calculation engine. So now that we've brought this in a little detail in this area just to give you an idea of what's going on with this particular mapping. We've got slope seating planes, about a 65-foot projection distance, 38-foot array height, and the top row is 36 feet relative to the finished floor. So pretty good slope to this space. Hit the calculate button in Ease Focus 3. I happen to pick 4 kilohertz, 1 octave band, A weighting here. This is the side view showing the calculation. I think we can see right off the bat, we've got pretty even SPL through the space. You see the HF attenuation settings and the box attenuation settings, which VenuePolar calculated for us. Look at the side view. Looking pretty good, but let's take a look at our deviation. Looking at our plus or minus 3 dB deviation, looking pretty good. Again, at 1 octave at 4K, coverage right out of the box. We could look at the 2 kilohertz bandwidth as we are here, and we have essentially the same, very, very even coverage. Yeah, you might be able to go in there and tinker with that, with the middle box, the third box. I've got just a very slight hot spot in the middle there. Maybe you go in and manually turn the box attenuation to minus 1.5 on the screen to address that if you choose to. But in the end, we met our target of 103 dBA average across the listening area if we look at our broadband coverage, and I'd say that VenuePolar did a pretty good job. Let's take a look at another model example. We're gonna take a look at this flat floor space, more of a traditional space. It's an 80-foot, 25-meter throw from the array, with a top box of the array at 28 feet, 8.5 meters high. And this one's, we're going to put subwoofers in the top of this array. But let's try and do this live and see if software is behaving today. And I assume everybody can see my Ease Focus 3 screen that I'm showing now with that model on it. So I brought this space in, and I did scale it already. I know it's 10 feet between the 2 points on the screen. I set my point of origin to the middle of the room, and I set my grid to a reasonable size, 5 foot square for my purposes here today, and I placed it in front of the room. I've got a seated audience. Just drew one area to keep it simple for now. I've got the sound booth back here. It'd probably be a good idea if they were able to hear also, but let's put an array in. So we're going to select an array, and we'll find our IV6 version 303 and click OK. And I'm just going to start out by putting an array in the center of the space. If I look at the object properties, as I said, it brought it in as a 12-element array to start. Since I have selected the IV6 array, my VenuePolar tab is active on the right-hand side. So my array height, I know from my site survey that my top box is going to be 28 feet within this space. And I'm just going to leave it in the center just for an example at the moment here. On this side, I'm not going to get really complicated, but I'm going to tell VenuePolar to calculate based on audience zone 1. I'm not going to worry about the sound booth in the back for right now. I'm not going to get fancy with anything in here, except I want subwoofers above the array. And if I left this at 95 dB, it's suggesting two subwoofers. So now, satisfied with the parameters that I've set in the start screen, I'm going to press the calculate button. And it says array not synchronized. Please change box count. All right, so we'll go over here. We'll change our box count to 7. It tells me that cabinet 1 and 2 want to be an IV6 118. It tells me cabinet 3 and 4 want to be a 5-degree vertical. That's correct. And 5, 6, and 7 would like to be 15 degrees. So I'll do 15 degree, 15 degree, and 15 degree. Cabinet quantity and model synced, and you see that VenuePolar's already calculated my attenuation settings. But now I need to send the array back over to the calculation engine. So VP to EF3. Now I'm going to first take a look at 1 octave, 4 kilohertz, and A weighting, and let's see how we did here. All right, our array is calculated. Just taking a look at the SPL here. That looks very, very even to me. And let's take a look at our plus or minus 3. Yeah, did a pretty good job. You can see the VenuePolar here. Let's pull out a little bit and look at a bit wider bandwidth. Let's look at 3 octaves wide at 4 kilohertz. Which is essentially about 1K to 10 kilohertz it's looking at. And yeah, I'd say that it created a pretty nice VenuePolar for the space. Could say that, okay, we're missing a little bit in the corners here, but perhaps it's going to be a left-right system. So we'll turn off our relative, take a look at the 2 kilohertz band, look at it 1 octave, and again, find that it's pretty good. We did this all, relatively quickly. Just left the target at 95 dB. We could certainly increase it. We have our subwoofers in the space, but the big takeaway from this here is it very quickly calculated the splay, calculated my array, calculated the aim points, and has given me all the information that I need if I were doing a point source array without taking a lot of time. Perhaps this is a left-right system, stereo system. So let's just take our array. We're going to move it across without recalculating at this point. Our horizontal aiming, we can either grab our aim line, or we can go in up here and show we want a 20 degree inward splay. And since I liked how that array worked when it was just single in room, I'm just going to copy it rather than recalculating each time here, and I'm going to paste it, and that will include all the VenuePolar information in it from that already calculated array. And we'll just aim it as so. And if I click on this array, see there's no information on it. This is where I can use the EF3 to VenuePolar button to pull the information in, which is also identical to the array that I just copied. Let's map this out again and see if it works out for us as a left-right array. Looks like we're in pretty good shape here. Look at my plus or minus 3 dB while it finishes calculating the side view on the bottom. Yeah, pretty solid. Yeah, might almost be plus or minus 2 if we were to look at that. Yeah, we're almost plus or minus 2. Let's look 3 octaves wide, plus or minus 2 dB. That all happened pretty quickly. I can't think of another software package that will give you good results, that quickly. We told her we wanted to, we did want to include subwoofers in the start tab here. Yes, I went for a modest 95 dB for the example. You could increase the number. Obviously, your heights and your rigging heights here, might change. I picked 28 dB as the top of, or 28 feet as the top of my box. I was using the GlidePoint array frame. You can select which array frame you want to use in here if you wanted to change it. But just a quick example showing how quickly we can arrive at a solution using the software. Practice makes perfect with this stuff. Hopefully, I'm not moving too quickly, but it's something you want to download and experiment with. Quick example, not going to do this one live. Took just a general listening space. It's about 70 feet deep, 21 meters. I placed a balcony over it. Calculated my array, and it told me that it wanted 7 elements. Hopefully the face of this balcony has some diffusion or some absorption on it, so that we're not sending hard reflections back into the space. Quick mapping here, even with balcony coverage, VenuePolar, and looking at ±2 deviation. Used a 2.5K center frequency for this mapping. We're about ±2, over 98% of the space, direct SPL for that particular bandwidth. So even with the balcony, you can see that VenuePolar calculated and left those top elements louder to create our VenuePolar to cover the balcony area, and we still have even coverage down on the floor listening area. So again, it's all about efficiency and speed of design and how quick can we get to an answer. Ease Focus, as I think all of you know, generates a full PDF report, which includes all the passive filter settings, display plates, the rigging frame, all the XYZ aiming information is included in that for the installers in the field. And it's simply under the File and Create Report section. The data is shown in the middle, and then we could, once you get on site, or if you configure it at the shop ahead of time, probably do it on site though, you can just move the jumpers based on the coding, the coding here. So box number 7, B1. So we'd select B for the bottom box as the jumper position where the dual jumpers move to, and 1. And then the HF attenuator would be at -1.5. Other important parts is the how many watts do I need? We do have a downloadable ALC to speaker cross-reference. It happens to show the IV6 in general. The suggestions using our amplified loudspeaker controllers and bridged outputs to drive an array of, say, 4 or 5 elements, at least if you need full SPL. You'd have a bridged output of a 1604D, and the same for 118S if you had a single sub up there. Suggest that too, but again, this is downloadable off the ALC page. Give you some quick direction. There's a number of ins and outs of powering these systems, but in general, as I said, 4 boxes, a bridged pair of 1604D channels. 5 to 6 1122 boxes, it may be more efficient to use a single channel of an ALC 3202D. When you get into 7 boxes and deeper, often you find yourselves with multiple bridged amps, or a couple of them to drive an array. But again, all the speakers are seeing the same signal. The full range speakers, obviously. We don't have an amp channel per speaker. Powering suggestions are just those, are suggestions, and feel free to give us in the solutions group a call if you want to talk in more detail. But we do have a downloadable array impedance calculator for more complex arrangements. Again, you can find this in Cornerstone. And it the impedance calculator considers the full range attenuation of the box. So if we're transferring the information from our focus report, we look at just the box attenuation settings, ignore the HF settings. And if you need the impedance calculations, whether it's to figure out cable loss or figure out the appropriate amplifier, very handy downloadable tool which you can use. It becomes really handy if you get into larger array elements, because you can start distributing the array across multiple amp channels if you have an 8, 9, 10 element deep array, and figure out the best load balancing across your amplifier. For advanced users inside VenuePolar on the Array tab, you can go in and manually adjust, as I mentioned, the attenuation and send it back to Ease Focus 3 from VenuePolar if you want to tweak and get that last half dB of smoothness. Yeah, we're only calculating direct SPL in Focus 3, but you can make the adjustments on each selected array and send that information back to the calculation engine very easily. You can, as I showed, you can bring in information from an array you already have inside of Ease Focus, assuming it's a GLL version 3 VenuePolar array, and make adjustments and send it back. Once you get maybe 2 or 3 arrays in a room and you see some things starting to build up, it can be useful to do that. Bring the array in, make your attenuation adjustments, and then send it back to the calculation engine in Ease Focus. The gains, we highly recommend that you do not double up on the gains. Leave the gains be in the left window, leave them at 0, and do all of your attenuation inside the VenuePolar Array tab, because they will be additive. It'll keep life a lot simpler for you. And as mentioned, an audience area must be fully intersected with the speaker aim line. VenuePolar would give you the option to optimize to both of these audience areas if you were to open up the window. But if you had your array over a seating area here, VenuePolar cannot optimize this seating area because the array is over it. Yeah, you can have it right in the front. You can have it a few inches or centimeters in front of it, but the aim line has to fully intersect the audience areas so that VenuePolar can consider them in its array calculation. All right, quick wrap up here. VenuePolar, it's an add-on, free-to-use, powerful tool which helps shorten the electroacoustic design process. It'll suggest an appropriate array configuration based on your input, and using the reporting function in Ease Focus 3, provide you a very detailed output report, something you could hand to the installers to take to the field, build the array with confidence. And as long as you got the modeling right, you can have a very high level of trust that the end result will be as mapped. A prediction's only as good as the input data. Again, you got to get the audience areas right, slopes of floors, heights of balconies, room and seating, accurate room seating dimensions, are a must in any of these programs. But especially when using VenuePolar. And room acoustics, you got to consider them during your site survey. Ease Focus 3 and VenuePolar don't know anything about the acoustics, so you've got to qualify the space in order to ensure that IV6 is an appropriate system for the space and will meet the customer needs in the end. It's a pretty quick overview of the power of VenuePolar. I encourage you to download the latest GLL, work with it some. If you have specific questions about this webinar or anything I presented, my email address is on the screen, dave.howden@biamp.com. And for your general technical support or loudspeaker solution group inquiries on any of our speaker lines, you can contact our Chester-based group at through support@biamp.com. I appreciate you taking the time to join us to learn a little bit more about VenuePolar. All right, everybody. Well, thank you very much. I hope you have a wonderful day, and everybody be safe.
Thank you.